Good morning, everyone. Today I want to talk about patterns and big picture. Patterns like the Lego blocks for software design. When you do an application, when you start doing a system like the Pac-Man, like the one that you review in the previous lecture, starting from scratch, like I need to decide my classes, and the only thing that I can do is this arrows things. It's like zeros and ones programming. You do not start programming with zeros and ones. You have some abstract elements that you use, ifs, fors, bars, even methods and classes. So in some point, these ones are going to become the zeros and ones. With software design, that equivalence, that place is patterns. We have patterns for the architecture and for the design. We need to review architecture later. So we're going to review design patterns, a few of them. When you think about a design pattern, this thing is a solution that someone create to do something. And when you are writing your programs, creating your software, instead of figure out the solution, instead of figure out what to do or how to connect the classes, there is one of these things that you can use. Examples. You work with this Pac-Man video game, and something that you need to do is the ghost, the enemy, need to know every single moment the position of the Pac-Man. Pac-Man is one class, ghost is another class, and one class needs information from the other. In terms of solutions that already exist, observing one class need to observe the others. The objects of one class need to observe the objects of the other class. And there is a pattern for that. There is a solution that you can follow, and you do not need to figure out how to do the sharing of the data between one class and the other. We need to review those patterns, because if you know those patterns, you can apply them when you do software, but also when you evaluate software, like Friday. Now, patterns, there are a lot. We're going to review a few of them, in particular from this group. There are 20 patterns, the original ones, the ones that usually you're going to find on the internet, like the glove patterns, the gang of four patterns. Those guys, the gang of four, the authors of this book. In particular, if you are planning to have a career in software engineering, if you're planning to have a career developing software, maybe that is one of the books that you want to read before finishing your school. It's a good book. Anyway, we're going to review some patterns, some solutions come from this book, from this original 23. Every single pattern, like the Lego block that I mentioned before, is a solution for a particular problem. I need to share data between two classes. That is the problem. And the pattern gives me the solution for that. The only thing that I need to do in order to solve my problem, share the data between two classes, for instance, is implement the pattern. The pattern, as you can imagine, among other things, include a class diagram. That is my solution. You need to do this. This is usually how the class diagram for that problem, for the solution of that problem, is going to look like. Take the class diagram, it's a template, customize that template to your problem, and you have your solution. Patterns. The 23 patterns that I mentioned from the book are divided in 3 categories: creational patterns, structural patterns, behavioral patterns. Today, just to give you an example, I want to review one of the behavioral ones. In particular, I am talking about this sharing data, and that sharing data is going to be that pattern. If you read the names, there is a class diagram that is the solution, but usually a pattern is going to have a fancy name, a name that is easy to remember, a name that we can use when we're talking about a program that we want to do, and the name is going to be something that helps us to agree in the solution. Hey, we're going to do this Pac-Man. The ghost needs to observe the Pac-Man. And in talking about the ghost need to observe the Pac-Man, we're sharing the idea that the class A is going to need access to the information of the class B. And there is a class diagram for that. And I am telling the programmer or my teammates that we need to implement that class diagram in particular. Go to the book, take the class diagram. That is the solution that we need. Observer, but obviously there are factories. And you can think about, well, if there is one particular class that is going to be creating objects, a lot of objects, that class is solving a particular problem, and we're going to identify that solution for that problem, creating objects, like, oh, we want this one to be a factory. In the system in ASU, there is one class that is the one that creates the object students with the ASU ID, with all your name and personal information. There is one part of the system that do that. Probably a factory class. There are obviously builders, singletons, prototypes, decorators. We're going to talk about the decorator one, facade, adapters. And you can imagine adapter used like in the real world. If I have a system and a second system, or one group of classes from one group of friends and another group of classes, and I want to connect them, and they are just like do not match, I put an adapter in the middle so I can connect two systems or two parts of my system. Interpreters, strategies, visitors, and so on. I just read some names for you, like they are names that you can hopefully easily remember. The point is not only remember the name, but also remember what kind of problem they solve, and more important, the solution. So you can just implement the solution when you are programming in the same way that you implement inheritance or using having that we already reviewed. So if that happened, when you think about your class diagram and your software, what you're going to have is your class diagram, instead of being something like the one that you review Friday, or all the ones that I shared with you from level 1 to level 6, you're going to watch your class diagram, you're going to solve your class diagram, and it's going to be like, okay, we have some kind of class A, and that class A need information from a class B. So A is an observer to B, and B is a factory because B is creating objects from something. Oh, by the way, there is a class C that is also observing B. So this B is providing information to A and C. Moreover, C is a builder. So C do something with this information. Probably A, the only thing that A is doing is observing. So maybe A is a graphical user interface showing you things because nothing else is happening there. But this guy is observing the factory, and maybe another pattern is being applied. I am using icons. And here some kind of work is being done with that information. And in another part of the system, you have these two classes, but you know what? This one and this one, this class E is a decorator of the class X. So the important one is X, but E is decorating X. And when you have those abstract ideas, it becomes easier to explain what is happening in the class diagram. Moreover, if each of these fancy icons, the observer, the factory, the decoration, the builder, have a particular, a specific class diagram that you need to follow, Your class diagram for your system become basically a collection of small class diagrams from the patterns that you need to connect. A Lego design is basically a collection of these Lego blocks. You have diversity of Lego blocks, you can connect them, and theoretically that is better than starting from scratch. Now, important thing, the patterns are solutions. And you can be thinking like, well, and they are the best solution, or maybe I can propose a better solution than the one suggested by the pattern. You know, creativity, innovation, all those kind of things. Well, to be honest, the solutions that you found in a pattern are good solutions. How do we know that they are good solutions? Because the patterns is not something that someone invent, create. The idea with the patterns is meaning, like data mining, but in this case, pattern mining. What is the idea? These four guys do not just create the patterns. What they did is review software that already exists and try to figure out the solutions in all of those softwares for particular problems. And what they found is, well, several of softwares that already exist, are working and are working fine, use these solutions. So mining solutions, mining the patterns. Behind a pattern is a solution. It's a solution that is working. It's working outside in different systems and that different people have applied before. It's a good solution. Now, always there is the possibility that you can propose a better solution. Innovation, right? The point is you're developing a piece of software, and in every step of connection between your classes, you have two choices. Number one, use something that already have been proved to work, or try to figure out an innovation. Most of the time, what you want is something that already works. Again, you're connecting classes. Maybe you want to do innovation in the service or the functionality that your software provides. But usually, unless you are working in a research and developing team, and particularly a software institute, what you want is, if this solution already works, I am going to apply that solution. Now, let's review one of them to be sure that it is clear what I am describing. Let's go for the easy one. Well, quotation marks, the most common one. This, you already are using this. I am going to describe this, but when you start learning Java, one of the things that you learn in Java, the listeners, action listeners, keyboard listeners, you use that for the Pac-Man, right? Mouse listeners. The listeners in Java are an implementation that basically emulate the observer path. We're going to do the comparison after we review the observer, but right now I am sharing this just for you to think about it. Observe, listen, is just, let's change the name. Anyway, observer or listener if you want. What is that pattern? The design for it. The problem that we solve with the observer pattern is the following. For any reason, we have an object, and you can think about this guy like a class, and that class have information. Information, a variable, an array, a data structure, whatever, information, a global variable. And that information change because maybe that class is reading from the internet, maybe that class have access to a database, maybe that class is creating data like random numbers, maybe that class is our Pacman. I am going to follow with the example of the Pacman. And that is the class that is reading for the keyboard from the keyboard. And that class have these variables. In this case, the information is the X and Y of the Pacman. So I have this class, and that class, for some reason, have information that is important to other classes. Again, a database, numbers from the internet, an important algorithm that is solving a problem, or use this yellow circle that is a character in a game, whatever. This guy have information. And there are others that could be one or more, I don't care, other classes. And they want to have access to that information. In our case, you can think about the ghost. For some reason, the ghosts need to know where the Pacman is, because if you remember, the algorithm for the ghost to move is, well, they move according with the position of the Pacman. So some of them, because they are going to follow, others are going to go away, whatever. They need the information of the X and Y of the Pacman. When you have this problem, this class need information that is here, you can start thinking like, well, we can use inheritance, we can use association, we can use composition, we can use both. Maybe we can put some diamond here and another diamond here and make crazy connections. Maybe we can put an interface in the middle. Maybe we can, this one can put information here and this other can take the information from there. You can start thinking about the solutions. And I am sure that you implement different ways in your own Pacman, or your space invader, whatever. And there are several solutions for that, using zeros and ones, the diamonds, the inheritance, and the association. However, this is the same problem that you have, for instance, in this program. If you think about this guy here with the plot, that guy is just drawing things. But that guy draw things maybe according with the data that come from this panel. When you have this graphical user interface, and in some class you have controls, and in another class you have this graphical representation, well, this one is observing that one in the same way that this one is observing that one. And we talk about listeners in Java. Listeners in Java. You use listeners when you want to do something, when the user click in any of the graphical widgets, like the buttons. The listeners are observing when the user is going to click here. And that is some class that have access to the keyboard or the mouse or whatever. That is the one that is receiving the input from the user. And then you have your program, and in your program, you want to know, observe if the event with the keyboard on the mouse happened. And well, the event with the Pacman and the ghost, two classes, and they want to watch each other. It's the same problem. The same problem, the solution, something like this. All this idea of observing things becomes this class there. And the idea is, it doesn't matter if you want to do the video game. It doesn't matter if you want to do this graphical thing with controls. It doesn't matter if you want to do a graphical user interface and you need to know when a particular widget is activated. This is your solution. This is a solution that has been applied and show that it works. If you are able to implement this correctly, you can complete this or this or this or anything with similar problem. Now, what is this? Well, very simple. The solution is a template. The template have template names, but when you take the template and adapt the template to your problem, you start using the pattern. For instance, here, there are two things, subject and observer. The solution defines two roles. the observer is going to be always observing a subject. Later, we're going to call this observable, the subject. And the first thing is those two classes are library classes. They are not from your particular problem, not for your solver, but something that already exists or something that you can create following the pattern. And then, well, we was talking about, for instance, a concrete subject. In our example, the subject, the thing, the one that have the information, well, is the Pac-Man. And we're talking about the observer. The observer, that is the name in the pattern, but in our problem, each of these problems can have a different name. I am going to follow with the video game. With the video game, the observer is really my class Ghost, because it's the one that is going to do the observing things. And inheritance, association in one direction, association in the other direction. The solution for two classes that want to share information is literally to connect them with association, to have parents for them, usually subject and observer, which, by the way, is going to help us to remember when we watch the diagram that they are following a particular role, and then another association in the opposite direction. You look in a class diagram, this thing, and that is the Lego block that is telling you that the two classes in red are sharing information. Somehow, A and B is interested in some kind of information that in A is changing. Block number one. Now, if we think about the problem, it's easy to understand. The solution in terms of the class diagram, hopefully, is like, well, it cannot be too complicated. Two inheritance, realization maybe, and two associations in opposite direction. I need to add two classes, extra classes, because the pattern is asking me to add those, and I have my own classes. Kind of simple. Now, if we review the details, it's like there are a group of methods that I am going to inherit from the class subject. There is one particular method that is important in the observer. And this one is the subject. This should be the information that I want to share with other classes. Obviously, that information should have a getter. This is nothing new. The class can have whatever you want. Obviously, you have information that you want to share. And as any other information, there are getters for that information. Nothing new, really. The only thing is doing inheritance. And the extra thing are in a different class. For the observer, the only thing important here is that update method, a particular method that is new or required for the class. And obviously, if you are observing something, maybe you want to have a variable to store what you are observing, but optional. Everything else, this, comments, you can put comments in a class diagram like in a source code, right? So for classes with a particular group of methods and variables, we can implement this. We can review first the source code alone, and then we can reuse that source code in a particular program, right? Okay, let's check first the source code alone. Question in the chat, game is an observer of the Pac-Man. we do not use patterns. So in your Pacman, unless you have previous knowledge of this, I do not use any pattern. I use zeros and ones and connect everything. So in your implementation right now, there is no observer. The recommendation could be the ghost observe the Pacman. And we can use the solution between the ghost and the Pacman. So far, the game only has a Pacman and has the ghost. In this example, if I think about your class game, and we need to connect game with the observer pattern, the game has, remember, the game having the Pacman, the subject, the game having the ghost, and then between these two, there is this observer relationship. So when you watch your class diagram, when you look at your class diagram, it's okay, game, zeros and ones is having, no pattern between Pacman and game or game and ghost. There is no particular pattern here. It's just a simple relationship having. But then we review Pacman and ghost. And one improvement that we can do to our implementation is instead of whatever we have right now. In fact, right now, we do not care about where is the Pacman. The ghost is moving without knowing where is the Pacman, right? So if we want to implement the algorithms for the ghost moving according with the Pacman, these are the connections that we can add to our class diagram. And with those connections, we're going to have access every single ghost to the data in the Pacman. We need to add the source code for the diagram. The key listener is the implementation of the observer pattern, but we are not doing the implementation. The implementation is already done in the Java API. The only thing that you are doing when you use listeners, and I need to show you this in the source code, this method here that is called update, and this class here, observer, in the Java API, for instance, this block here is your class action listener or key listener or mount listener or whatever. And for the action listener, this method update here, this update here is the method action performed. When you are using listeners, what you are doing is the implementation of this part of the pattern. The other part is already implemented in the Java libraries. Makes sense? Well, I need to show you the source code. This pattern is the reason because when you implement listeners, they ask you for this method. And that method is in this interface, action listener, if you're using actions, or all the methods that you need to complete when you use key listeners or mount listeners, is this inheritance or this implementation here. But the reason because you do that implementation or because you do that thing is following a full pattern that observing, listening. Let's review the source code and then go back to the comparison. Anyway, remember subject, observer, the concrete observer, the concrete subject, and these connections. Remember this shape. This is the shape of two classes sharing information. That is the shape of the observer. The details, well, the inheritance, and use opposite directions, the association. Source code. Let's see. You are telling me that I need a class, and that class, the only thing that it's going to do is to force any other class that inherits from that one to have a method with a particular name. In this case, update. I need to make mandatory for some classes to have this method. So option number one, I do not need a body for that method, not yet. The body, I need the body in whatever class implement this one. So the only thing that I need, and that is the first part of the pattern, the top, is this observer class. That the only thing that is going to do is to force a method with a particular name. The name should not be updated. I mean, you can use any name here that you want. I give you the example before with action perform, or there are several methods for the key listener, mouse listener, whatever. In this example, I am using update. Nobody. This is the parent. The parent used define the contract, but I don't care about the content yet. And you know that if you do not care about the body or the content, well, that one could be an after class or even an after class without any variable, an interface. Observer, this one, after class, interface, whatever you choose in your implementation. The listeners choose interfaces. That is the reason, because you implement whatever listener you want to use. And makes sense. Nobody for the method. This is step number one, an interface observer. Easy. Now, the consequences for that is when you have that observer, every time that you want to do this part, the inheritance, well, if you have an abstract class, you use extend. If you have an interface, your choice, you can use here implement. Nothing new, really. That class, this one, the important thing that this one needs to do is to provide this method, because the pattern tell me that I need an update here, and therefore this one need to have that update. Why? Because what is going to happen is that the subject, the other class that I am observing, is going to tell me every single time that the data that I want to know change, because that class is going to call this method update. Observer. In programming, the things are very special. For instance, in the classroom, the professor is observing the students. Maybe the students are doing an exam and the professor is observing the students to avoid copy paste, right? In programming, even though we define that professor is observing students, really the program is about students are going to call a method in professor, because students are the ones that are going to notify the professor, I am cheating in my exam. That is what we're programming here. The observer is not going to do anything with the subject. The observer is not the one that is going to call a method or is going to go and search for changes. The programming that we're doing, we're defining that the ghost is observing the Pacman. But really what is going to happen is the Pacman is the one that is going to be calling an update method in the ghost to tell the ghost, I am moving to the next position. Why we do that? Because it's cheaper in programming. Sorry, performance. Instead of think about the classroom, instead of having the professor observing everywhere, it's like the professor can go to sleep and the student is the one that is going to say, hey, I am cheating in my exam. It's a better programming approach, right? So that is what he's doing here. Very good question. The update do not have parameters. Why? Because sending parameters have a cost in the memory. The only thing that the subject is going to do is to call the method, and calling the method to tell, hey, I am doing something that you maybe need, you are interested. It's just knock the door. Something is happening, and maybe you want to know about it. In the original pattern, it's just, I call the method like sending a signal that something important is happening. Like, you told me that you want to observe me. I am doing something that maybe you care about it. That's it. Later, this guy here, and I am going to complete the source code, but inside of the method, this guy, remember, this is the observer. This one is going to call a method in subject. It's going to call a method here, and that is the back. It's going to be a getter. Here I have a public variable, but it's going to be a getter, and it's going to call a getter, and the getter is going to say, hey, give me the values of these variables that you have. You are the one to tell me that something changed. And if I am interested, if I have time, I am going to ask you for the data. Call, calling a method back. Notification, get me the data, a getter. Yep. Remember, very important, the patterns are templates, and the template is the original solution. Again, in the original solution, for instance, this guy, notification. For the listeners, as you mentioned in the chat, one thing that they do, this update, the action performed, have parameters, but it's not the original solution. For some reason, the people that do the listeners change this. It's not exactly observer pattern. Well, it's the listener pattern. I change something, now you know what. And why not? I can change the name. It's possible. Anyway, I am almost done with the connection. You notice calling a method, inheritance. I am missing the other part. The other part here, very, very important. I need a subject in order to call the method from subject, right? What is going to happen is obviously that I have a constructor here, and every single time that I construct an observer, I am going to pass as a parameter for the observer a subject. So think about this. I am going to pass as a parameter for the ghost a Pacman. I am going to give the ghost as a parameter, a reference to the Pacman. Why? Because the ghost is going to be calling getters in the Pacman. When? When the Pacman notify with the update that something changed. Getters and setters, and the reference to communicate with the subject. It can be global. If you notice, the only difference between the observer and the listener, this variable in the listeners is not there. That variable is the one that you receive here as a parameter, and that variable is the one that you use inside to know who called the update. Remember, you can have the same action listener for several widgets, and this, the widget is the subject, and this variable is the one that you receive as a parameter, and the only thing that you do with that variable is call a getter, like get me your name or get me your label, and then you know if the action performed was called from the bottom okay, or from the bottom cancel, or whatever you have. Listeners, observers, global, locals. Anyway, almost done. Subject. In the subject, a variable. What is the variable? If I am the subject, and this is the class that you have above, something that as a subject I need to do is to remember who is observing me, so I can tell them when I do something that maybe they want to know. As a general solution, I can have here a list of observers, a list of other objects that are observing me, or I can have just one, depending on what you want to implement. The general solution is a collection. The collection, you can use whatever data structure that you want. In this example, a list. You can use an array, whatever. I need to remember who is observing me. And if you think about it, in order to handle this list, something that you need is a method to add information there and a method to remove information. The original names in the pattern, attach, detach, but if you think about your listeners, this attach is your method add action listener, or add mouse listener, or add whatever listener you are adding. And obviously you have an equivalent remove. And the important method, this one. Now, do you remember what is the parameter for add action listener, or add mouse listener, or add whatever? You use this. This, the pointer to the class that implements the listener. If your class implements the listener, your class is a listener. In this case, an observer. The parameter for the add is an observer. Wait, to the subject in the constructor, I share the reference to the observer. When I create a ghost in the parameter for the new, I share the Pac-Man. But now you are telling me that I am going to add the ghost to this list that is going to be in the Pac-Man. So are you telling me that you have two classes and this one have a reference to this one and this one have a reference to this one? Obviously, yes, because this one is going to call a method here and this one is going to call a method here. So both need to know where or which one is the other. Solution. This method, did you notice what happened in that method? I have a list of all the objects that are observing me, and I add them with this method. This method notify is basically a for loop in the list, and the only thing that I am going to do is for each of those objects that are interested in what I am doing, when I want to notify something, I am going to call the update method in those objects. How do you know that I have an update method? Because they are observers, and this observer is an interface or an after class, and this one make all the family below to have this method. The interfaces give you the guarantee that a particular class like this one is going to have a method with a particular name, and you can use it. Subject, a list of observers, adding, removing observers, and this notify that is going to call the update method that we described before. So far, nothing crazy in programming. Now, the last one, the concrete subject. The concrete subject, like the Pac-Man, right? If this were the Pac-Man, the information that the Pac-Man wants to share, in this case, is a string. For the Pac-Man, could be two numbers, X and Y. In the example, it's only one variable. Again, you can have 20 variables, an array, a data structure, whatever. This is the information that you want to share. And for that information, getters and setters. You already have getters and setters. Extend subject. What is happening when you do extend subject? This class is going to have all of this. Separation of concerns. This class have all the new things that you need. This class is still the Pac-Man. And the only thing that have is what the pacman should have, variables, getters, setters, for whatever functionality this class is doing. That's it. What about the main? In the main, you're going to find similarities with your listeners. Think about this like concrete subject. Okay, that one was the pacman. Concrete observer. New concrete observer. And let's share with him the pacman. Because you want to observe him, right? Okay. Now, for the pacman, add. If you do not want to use attach, add. We could use add observers if you want, or add listener or whatever. Add G. Pacman, no G, and G, no the pacman. They are connected. And I can ask this pacman to move. Because you remember that we have this calling the method up, down, and so on that we're calling in some place. And what if I ask every single time that I call pacman up, also a pack dot what is going to happen? Well, this method notify is a method that the pacman is inheriting from the class subject. And there is going to be a lot of things that happen, but at the end, a method update in the class gods is going to be called, and that method update is called every single time that the pacman change the position. And that method update in the class ghost, because ghost is an observer, is going to have the opportunity to access the pacman and call the get x, get y, because all the structure is there for that to happen. Observer. A recipe of what I need to do to share data between two classes. Make sense? Now, this is from scratch. But you know what? If you want to use the observer in your programs, obviously, I need a subject and I need an observer. These two classes are not something in my program. These two classes is something that I need. The Java API give you those classes. And this is your ghost, this is your pacman. The only thing that you need to do is to connect your classes, your problem, your software with something in the API. But we will review an example in the next lecture, okay? Subject can be whatever you decide, an abstract class or an interface. In particular, in Java, it's going to be an interface. Yep. All these methods, the linked list to store the observers, the attach, the detach, the notification, and even the name that we need to use here are going to be already defined. Where? In the API of Java. And we will review that example in the next lecture. Good? Okay, guys. Thank you. See you next lecture.